Yaskawa.
The Technical Training Department of Yaskawa America Incorporated presents Features and Benefits of the U1000. Hi, I'm Steve Kaler, and I'm here to provide an overview of Yaskawa's U1000, a variable speed drive that introduces a new chapter in energy savings and power quality. The U1000 is different than other drives. In fact, it won Control Engineer's prestigious Engineer's Choice Award for the most exceptional products based on technological advancement, service to the industry, and market impact. The uniqueness of the U1000 lies within the matrix technology itself. Unlike conventional drives, Yaskawa's matrix technology employs a system of 9 bidirectional switches arranged in a matrix to convert a 3-phase AC input voltage directly into a 3-phase AC output voltage. And this eliminates the need for a rectifying circuit and a DC smoothing circuit found in conventional AC drive inverters. The U1000 is ideal for industrial applications that require regenerative capabilities and low harmonic distortion. It also provides near unity power factor, greater system efficiency, compact design, variable 3-level output, and expanded motor control capabilities. The U1000's built-in regenerative capability is ideal for escalators, elevators, centrifugal separators, presses, and test dynamometers. The low input harmonics and high input power factor make the U1000 ideal for fans, pumps, cooling towers, and compressors. To understand what makes the outstanding benefits of the U1000 possible, let's step back for a second and look at how power conversion is typically achieved. Conventional drives convert AC to DC through a diode rectifier and bus capacitors, then convert DC back to AC through an inverter section. And this is called indirect power conversion. The rectification process generates low-frequency current harmonics that can be as high as 100% of the fundamental current. The rectification does not produce a solid DC source, which means large amounts of capacitance are needed to provide a more stable DC source. Additionally, a diode rectifier bridge only operates in one direction, meaning they can only charge the DC bus. Any energy put onto the DC bus must be removed through other means, such as external regenerative options or by using external braking resistors. The U1000 is unlike conventional drives because it directly converts AC to AC. The U1000 does not use a diode rectifier bridge or bulky capacitors to smooth out the DC bus. The U1000's revolutionary matrix technology uses a single switching stage to efficiently convert the 3-phase AC input to an adjustable AC output required for precise control of the voltage and frequency supplied to the motor. 9 bidirectional switches are employed to allow power flow in both directions, meaning the unit is fully regenerative. And we'll talk more about that in a moment. The direct manipulation of the input voltage allows the U1000 to be fully regenerative and does so without introducing high levels of harmonics onto the power supply. Time for a check question. What is the major issue with the rectification method used on conventional drives? Answer: this rectification method generates low-frequency current harmonics that can be as high as 100% of the fundamental current. Let's take a closer look at the benefits achieved by using the U1000 industrial matrix drive. Regenerative energy. As I mentioned, one key benefit is the drive's ability to properly manage regenerative energy, commonly called regen for short. Regen is defined as the electrical energy created as a result of a motor shaft turning faster than the drive's output frequency. Now this occurs because an overhauled motor acts as a generator. You can think of it in this way. When a motor turns, it consumes energy. But when the motor is turned by something else, it generates energy. In other words, energy can flow backward when a motor shaft is turned by an external force. Any condition that will overhaul a motor will result in regen flowing back into the drive. For instance, applications with high inertial loads, such as engine test systems, conveyors, presses, mixers, and winders, or rapidly decelerating loads, such as machine tools. For a further understanding, let's say we have a downhill conveyor with a standard drive running the motor connected to the conveyor. In this application, there's a lot of regenerative energy due to gravity. The drive will command the motor to run at a certain speed in a given direction. Now, due to the weight of product on the conveyor and the force of gravity, the conveyor will naturally want to accelerate downhill without needing the motor to perform any work. When the conveyor starts to run faster due to gravity and the load, the motor must hold the load back to maintain the commanded speed. Now this is called holdback torque. During this time, the motor is being overhauled and is in constant regen. The regenerative energy is applied back to the drive. In the case of a conventional drive, regenerative energy gets stored in the drive's DC bus capacitors. The energy stored in the DC bus capacitors must be dissipated through additional peripheral devices, such as dynamic braking resistors, if any significant amounts of regeneration is present. Otherwise, a conventional drive will experience overvoltage faults. The U1000 eliminates these overvoltage faults and actually directs that previously burned off, wasted energy back into the supply. The U1000's unique method of putting regenerative energy back onto the supply is what allows the U1000 to launch a new chapter in energy savings. It's Yaskawa's greenest drive ever. The U1000 offers significant energy savings by accomplishing regenerative operation without connecting any special external device. Common external regenerative solutions include large dynamic braking arrangements, consisting of dynamic braking resistors and transistors. Other external regenerative solutions utilize active front ends. The U1000 is an all-in-one package, which eliminates the need for those conventional, bulky, and expensive solutions. Ready for another question? What condition can cause a motor to regenerate? And the answer, any condition which can cause a motor to be overhauled will cause regeneration. Now let's discuss harmonics and the benefits obtained using the U1000. Harmonics occur whenever you rectify AC to DC, which is what every AC variable frequency drive does. When using conventional drives, input current harmonics are present. Conventional drives with diode rectifiers will generate low-frequency input current harmonics. Current harmonics cause heating to the supply transformer and lead to distortion of the utility's power supply voltage. Diode bridges only rectify voltage when the supply voltage is higher than the DC bus. Due to this method of rectification, conduction is not continuous, which is why conventional drives are also referred to as non-linear loads. The problem with diode rectifiers drawing discontinuous current is that large amounts of current harmonics are generated. Diode front-end sections can expect a total harmonic distortion, or THD, of up to 100% of the fundamental current draw. One conventional solution is to add additional impedance before the drive in the form of an AC line reactor, or DC link choke. The additional impedance will help linearize the current and reduce input current harmonics, but the harmonic content will still be between 30 and 40% THD. If harmonic content and system efficiency are a concern, even these levels of THD may not be acceptable. Another conventional approach to mitigate harmonics is to add an active front end to draw power from the line without generating significant harmonics. Active front ends use IGBT front ends to maintain consistent current draw, whether in a motoring or regenerative condition. The IGBT front ends are the same devices that are on the output section of the drive running the motor. Active front ends usually require an additional unit to regulate the power draw and a separate filtering package to clean the output waveform. An active front end's ability to regulate and filter its output results in current THD levels that can be less than 5%. Unfortunately, these front-end packages are fairly expensive and are bulky because of all the separate equipment required. Due to the U1000's revolutionary matrix technology, the U1000 directly converts AC power to AC power using bidirectional switches and a sophisticated switching pattern, all within a singular, compact design. With harmonic characteristics of less than 5% THD, the U1000 is fully compliant with the most stringent levels defined in IEEE 519. Let's take a second to review. What makes the U1000 drive different from traditional drives? The answer: the U1000 features matrix technology, which utilizes 9 bidirectional switches to achieve direct AC to AC power conversion. The U1000's topology allows for 4-quadrant operation with full regenerative capabilities at or below the most stringent IEEE 519 harmonic distortion levels. Next, let's talk about some of the other important product features and benefits of the U1000 industrial matrix drive. These include its high near-unity power factor, greater system efficiency, compact design, variable 3-level output technology, and expanded motor control. We'll start with near-unity power factor. Many conventional drives boast of high power factor. In most cases, they're only referring to displacement power factor. Displacement power factor is the phase angle difference between the voltage and current waveforms. Displacement power factor does not include harmonic content. To understand harmonic content's effect on power factor, you have to use true power factor. True power factor is an expression of both displacement and harmonic content. The U1000 drive has a true power factor of 0.98 or higher when operating at rated power. The U1000 will improve true power factor by approximately 21% over a standard 6-pulse drive without a DC bus choke. This translates to higher system efficiency and less losses. Another important benefit of the U1000 is its greater system efficiency. Conventional drives use external devices to reduce harmonic levels. External harmonic countermeasure components, such as input AC reactors, harmonic filter reactors, and capacitors, are not necessary with the U1000. The U1000 helps you save wiring, space, and energy costs. Due to reductions in wiring, equipment size, weight, and power utilization, the U1000 offers quicker startup times, which reduces manpower, man-hours, and overall startup costs. The U1000 goes a step further in optimizing efficiency with the introduction of Eco Mode. Conventional drives switching to and from commercial power typically require additional components. The U1000, using Eco Mode, can connect the input power directly to the output power without any additional components. The U1000 seamlessly transitions into and out of Eco Mode to further improve harmonics and reduce system losses. Another important feature of the U1000 industrial matrix drive is its compact design. Because you don't need external devices to mitigate harmonics and manage regenerative energy, you can construct your system even when there's limited space available. The all-in-one package of the U1000 eliminates the need for various external components. Now, to give you a better idea of the U1000's smaller package size, here's a typical configuration which can include external components such as an external regenerative drive or dynamic braking system, input AC reactors, harmonic filter reactors, and capacitors. These components are not necessary with the U1000. Compared to this configuration, the U1000 has a 65% size reduction. Wiring is reduced 70% from 20 wires down to 6. That's because the U1000 is just 3 in and 3 out. Eliminating external devices also eliminates the wiring and space required for those devices, simplifying the enclosure design, installation, and maintenance. Weight is reduced by 81%, and power consumption is reduced by 19%. With all this talk about reduced size and wiring, do you remember how many wires are required for your main power and motor connections? That's right. There are only 6, 3 in and 3 out, and that's a 70% reduction from traditional low harmonic regenerative packages. Another important feature is 3-level output. Because matrix technology produces a variable 3-level output, there are fewer surge voltages that could potentially be harmful to the motor. Compared to a conventional 2-level inverter, the matrix drive can reduce the average surge voltages seen by the motor by an average of 31%. The reduction in surge voltages also results in a reduction in common mode current. Another important feature is expanded motor control capabilities. The U1000 incorporates 3 permanent magnet control methods. The control methods allow the U1000 to operate both surface permanent magnet motors, or SPM motors, and interior or internal permanent magnet motors, or IPM motors. Now that we've looked at important features and benefits of the U1000, let's take a moment to discuss capacities and certifications. The U1000 is available in 2 voltage classes. Each capacity drive is dual rated, with one rating for heavy-duty operation and the other for normal duty, making it ideal for constant torque and variable torque applications. In the 240-volt class power range, models are available from 28 amps up to 248 amps, from 10 to 100 horsepower. In the 480-volt class power range, models are available from 11 amps up to 414 amps, from 7.5 horsepower to 350 horsepower. Higher capacity U1000s will be available in the near future. Yaskawa's commitment to reliability and quality sets the industry standard, and the U1000 is no exception. With a mean time between failure rate of 28 years and a 10-year lifespan for fans, caps, and relays. To protect your investment, the U1000 has integrated input fusing and a 100K SCCR. Take advantage of the U1000's embedded functional safety, which is certified by TUV for SIL3 and PLD. This embedded functional safety can increase production uptime for applications requiring routine maintenance or occasional intervention. Certifications for the U1000 include RoHS, TUV, UL, CSA, and CE. Well, let's test your memory a bit. What voltage classes are available for the U1000? That's right, there are 2. There is both a 240-volt class and a 480-volt class. Our next topic is software features. The U1000 incorporates the advantages of matrix technology without losing any of the software capabilities that make using and applying Yaskawa drives so great. Specifically, the U1000 shares common operating features with Yaskawa's industrial standard A1000 drive. Programming can be done through the full-text multilingual LCD keypad, Parameter presets make startup faster and easier to meet specific application needs. There's an abundance of monitors to display operation status such as frequency, current, and voltage levels. There are also monitors to make troubleshooting a breeze. Up to 10 of the most recent faults are stored to memory. Here's an exciting new addition to the U1000, power monitors. With power monitors, you can view the power consumed and produced, which allows you to track power usage. And to take it a step further, the power monitors of the U1000 convert kilowatt hours to currency, so you can track dollars saved using the U1000. Motor auto-tuning can be used to tune the matrix drive to the connected motor's specifications, resulting in the highest performance possible while maintaining maximum efficiency. Auto-tuning is available for both induction motors and permanent magnet motors. The U1000 will work for a wide variety of applications, as the output frequency to the motor can be varied from 0 Hz up to 400 Hz. These and many more software features are available in all of the U1000's induction machine and permanent magnet motor control methods. Well, we have one more question for you. What special monitors are available on the U1000? The U1000 features monitors which can display power consumed and power regenerated. These monitors can be programmed with your power rate price to show how much money is being saved from regenerative operation. Next, we'd like to talk about some of the hardware features. A wide array of programmable inputs and outputs are available for even the most demanding applications. All analog and digital inputs and outputs are fully programmable. Also, all analog inputs and outputs can be set up for 0 to 10 volts DC or 4 to 20 milliamps. Most notably, the U1000 has 2 safe disable inputs, which provide stop functionality in compliance with safe torque off as defined by the IEC. Should you ever need to replace the drive, the removable terminal card automatically backs up all your programmed settings, making drive replacement simple and keeping downtime low. Next, let's talk about some of the available options. In addition to using the keypad, programming, monitoring, and parameter backup can also be accomplished on a PC using Yaskawa's free Drive Wizard industrial support tool. Also available is Yaskawa's DriveWorks Easy software, which can be used to create custom mathematic and logic functions inside the drive by using a variety of function blocks. This can eliminate the need for an external PLC. The U1000 has built-in Modbus RTU serial communications. Additional serial communication options are available with an option card, including DeviceNet, Ethernet IP, EtherCAT, Modbus TCP IP, Profibus DP, and Profinet. Additional control options are available for analog inputs and outputs, digital inputs and outputs, and support for a wide variety of motor feedback devices. The U1000 is Yaskawa's greenest drive ever. It goes beyond conventional drives by utilizing matrix technology to provide outstanding harmonic mitigation, energy savings, and regeneration capabilities in a single standalone component. And best of all, it's from Yaskawa, and that means a high standard of product excellence, high mean time between failures, low cost of ownership, quick response to your questions, free technical support 24/7, and a great return on your investment. You get it all from Yaskawa, the world's largest manufacturer of AC drives and motion control products. At Yaskawa, we do everything we can to make each experience with us a great one. Because to us, it's personal.